talk about Difflicious, which is a library that I've been working on to provide readable and flexible diffs for your tests. A little bit about me. I work at a company called Medidata. We make software for clinical trials. And I'm on Twitter and GitHub, so you can find me there with this handle. Trying to be a aspiring comedian on Twitter, but I can't really quit my day job yet. Yeah, so I like types. I like languages that are powerful, like Scala, and I use them to build interesting libraries. I think that helps me solve problems that I have, and Difflicious is one of them, which I'll show you today. Let's get started. So imagine, let's tell a little story. We have you on a Friday, hacking on a task that you started in the morning, right? You've been playing your type Lego to fit the types together because it's not compiling, right? And finally you got it working, right? You pass that int into that function that takes an int, and boom, everything compiles. Awesome. If it compiles, it should work, right? The good news is, yeah, you start your application, you test your happy path, and everything seems to work fine. Excellent. But then before you check in, of course, you have to run the test to make sure they still pass, but then they are failing. Now, there might be a few reasons. For example, because you just changed the business logic, so there are things that the previous expectations are different now, right? Because the logic has changed, so the tests are failing. That's fine. Or perhaps there are some edge cases that you haven't accounted for, and now the tests are telling you that, hey, you got this bug, you better fix it. So tests are failing. That's cool. It's okay. Should happen. But then the test failures look like this. And whenever that happens, basically two things are different, right? But it just prints them out, says it's not equal to that, but it's hard to tell what's going on. And this is normally my face when I see something like this. Yeah, same hand gesture as well, actually. And it's Friday afternoon. It's time to go home. Okay. So on your way home, you started dreading Monday, right? That test failure is not going to go away. It's still a sea of red, the same sea of red you're going to see on Monday. You start thinking about your life choices, how you end up here, right? Dealing with all this mess. And then you thought about your dream of moving to the hills. And you thought about your ex-colleague actually who moved to the hills and become a goat farmer. And it seems like all of a sudden, that career is quite lucrative. Now, of course, I'm being a bit overly dramatic here, but I think we can all agree on what we saw there, right? The tests, we want them to be nicer. We want to be able to say if a test is failing, we want to tell us what exactly is wrong, right? Directly in front of us. So a lot of the time we have our business logic running, we have two complicated things, and only one little field is different, right? And then the moment you see that difference, I know how to fix that, and you go and fix your business logic or fix your tests. But then a lot of time with the sea of red, you spend a lot of time trying to find out what is exactly different between the two things. And we also want a bit of flexibility in our comparison. So all we have is a direct equals, but that's not what we want, right? I'll give more example on this later. And these are the reasons why I decided to build Difflicious, the library, to help solve these pain points that I felt ever since I started working professionally as a developer. To start, what you want to do is you want to add add Difflicious to your test dependencies. We have an integration with two test frameworks. So you have MUnit, which I'll be showing today, and you have Scala test as well. The library is available for Scala 2.12, 2.13, and Scala 3. So what we typically do at a high level is you want to first create some differs. So what are differs? So differ is a case class that knows. Sorry, it's not case class. Differ is a type class that knows how to diff things of a type. So if you have a differ of int, that means the differ of int knows how to diff two integers. You have a differ of cats and knows how to diff two cats. So typically you will either summon them or you derive them, and then later on you can also configure the differs. So about summoning, right? A lot of the time you will be testing things that are from the standard library, like lists, ints. So you can use differ.apply to summon an instance of it, and then use that in your assertions. Because you'll be seeing this later on, I just want to explain it now. And finally, we have our different instances. Then we can take around and diff the different values. Okay, enough bullet points. Let's look at an example. So at the top, we have our imports. We import our differ class. We import our implicits for Difflicious, and we also import our munit integration that provides some extension methods on our differ. So let's say we have a case class called foo with two fields, int and a string. First step, we want to create our differ. So here we create our differ for foo, and because Difflicious knows how to diff an int and knows how to diff a string, right? Those instances are available in the implicit scope. It's able to derive a differ for foo. So now we have our differ, and we have some example values here with expected values and actual values. We can call assert no diff extension method on our differ and pass out the two values we're comparing. And then we will see an output like this. So your test will fail because the values are different. And in here, we can see that it's telling us that the first field, the integer, is the same, but then the second field is different. Right? On the left side in red, we have the actual value we got, which is b, but then what we're expecting in green, we're expecting a string of value a. Next, we want to move to data structures. So by default, Difflicious come with support for seeks, so lists and vectors, supports maps, and it supports sets, so it knows how to diff these things. For sequences, what you do is if you have a list of ints, right, it's going to pair things up by their index and then diff them individually. For maps, it's going to pair values up by their keys and then diff the values. For sets, it will use equals because that's only viable default behavior. So let's say we have a flat warming party, right? You move to a new place, your friends are showing up with different presents, and we're expecting our two friends to come along, each bringing one gift. But what ends up happening is that Sven is nowhere to be seen. So similarly on line 15, we have we create our differ, because in this case Difflicious already supports vector, maps, strings, and sets. We don't have to derive anything. We can summon it, right? So Difflicious is gonna find them in the implicit scope and say, okay, I can construct a differ of this vector of map of blah blah blah. Now we have our differ. We call assert no diff on it again. Pass the two values we're comparing, and we get an output like this. So we can see that Bono showed up with some extra plates. We're only expecting one gift from him, but he showed up with two. And then we also see that Sven is nowhere to be seen, right? We were expecting Sven, right? Expectation again in green, but then he's not there. So maybe I think Sven had an emergency, so he has to pass his gift to Bono, who brought it along. So previously I talked about the default behavior for diffing sequences and sets, but a lot of time it doesn't give us enough information, right? It can produce confusing behaviors and outputs when things don't match up. So here's an example. Let's say we now want to diff two lists of cats. We're expecting Lucy and Bono to show up. But then what we actually got is we got Bono and we got Sven. So you will see that I intentionally put Bono in a different index location to show you the output. And then finally, we have our assert no diff at the bottom as well. I actually commented it out because these are actually running code. So I don't want to, if I actually run them, it will actually throw an exception, right? Because it's an assertion. So you do your diff, and you get an output like this. Now this is a bit weird, right? Because we know that Bono exists in both lists, but somehow when comparing, because it's comparing by index, the output's not very nice. It's telling us that Bono turned into Lucy, and then Sven turned into Bono, right? We want something nicer. We want to say, let's when comparing a list of cats, let's pair them up by their name. Okay, so you can use this pair by method on differs. You can start configuring it, right? We're getting into the configuration of differs. So again, we summon our differ of list of cats. So there's a behavior, default behavior for differs. And then we call the pair by method on this differ instance. So now we're telling it that when we're comparing two lists of cats, we want to make sure we pair the cats by name to compare. So what that's going to do is from each list, it's going to take their name, right? A cat with Bono is going to find a cat named Bono in the other list and then pair them up for comparison. We call our assertions again, and we end up with a nice output, right? It's pairing up Bono. So we say, okay, Bono, we got a wrong age for Bono. And it's also telling us that Sven is an extra that we got. We're not expecting it. And then we're also missing Lucy. Because it's pairing by name, it's not able to find an equivalent in the other list. It's printing it out as something that's missing or something that's extra.
So we've got a question in chat, and I think I know the answer to it, but it was asked, can this library be used in Java?
I think it will be a little bit difficult because it utilizes macros. Which I'll get into. So at this point, and I think because you have derivation as well, so I think this will be very, very difficult, if not impossible, to use from Scala, unfortunately.
Kind of what I expected. Thanks.
Cool. But I think that the underlying concept can work. But I think in Java, I guess nowadays you have these you have what they call like data classes or something like that, right? They start getting into this idea of having pure data classes instead of classes with behavior. Maybe you can do something with annotations and those things, but that's out of my realm of expertise. It will be a different library anyway. Okay, so next up we have behaviors. Sometimes we want to be able to ignore certain fields in our case classes because maybe we just can't compare them, or maybe we don't want to compare them, right? So for example, if you're running some integration tests, we may have some IDs that are generated outside of our control, right? So we can't really predict what the IDs will be. Or maybe in the tests, in this particular test, you don't really want to test the whole thing. They are not relevant, or you have a big complex data type, and you only need to test behavior of like a small part of it. So in that case, you want to be able to ignore it. So let's look at an example. So enough about cats. Let's look at dogs. Let's say we have a dog registration service. Right? So it's just a function here. You pass it some dog data, and then it will register the dogs, giving each of them an ID, and then give it back to you. So the dog data currently is just the name of the dog, and then with the actual dog we get an extra ID for each dog. Similarly, we start by deriving a differ for the dog. And then we have some data, right? So let's say we have our data for 2 dogs that we're going to put into this service, right? And it's going to return us the 2 ideally expected outcome of 2 dogs as well. And you can see that on line 3, because we say we're going to ignore the ID of the dogs, we can put in any values for them, right? So we put in zeros here because they don't matter. And then now we want to start configuring our differ, right? Because we're comparing two lists of dogs. We first summon the differ for list of dog, right? It's going to use that instance on line 1 in the top code block. Right? It's going to take that dog differ, use that. Now we have we know how to diff a list of dogs. And then we can say, for each of dog, when you're diffing them, I want you to ignore the ID. And then we do our assertion, and we should have an output like this. So here you can see that for each dog, the ID type has a ignore gray text on it that tells you that we're not comparing the IDs at all. So that can be anything from the service, right? Because it's generated. But then it's also correctly pointing out that we have a typo in our second dog's name. So let's say we fix that typo, we run the test again. The test will pass because now if we ignore the IDs, then the two sides are considered the same. So what I just showed you here with this ignore at is it's a concept that I think I developed for Difflicious. Is to be able to deeply configure your differ, right? How you diff things. So we have this path expression, right, that you pass into ignore at. It's not some formal term. It's just a name I come up with it. Where you can say, I want to be able to ignore for each dog in this list. I want to ignore the ID. So what this allows to do, right? If you expand this to a much more complex data structure, let's say, I don't know, a zoo of dogs and then with employees or something like that, right? You can start with a differ of dog zoo, and you can deeply configure how you diff each dog. You might want to ignore the name, or you might want to ignore the ID, or perhaps you want to, when you're comparing the dogs, you might want to pair them by the ID or pair them by their name. Right? You can do many things. And what the deep configuration allows you to do is that it allows you to reuse kind of the default instance where it compares everything using the default behavior. You can change the behavior for each test immediately. So for this test, I might want to diff with this behavior, but for another test, I might want to change into another bit behavior. Might want to ignore the name of dogs when diffing dogs. For configuration, there are also other methods. For example, like we talked about dog zoos. So now we have employees and working in the dog zoos. Let's say on line 4, we have some configuration with, we want to configure our list of dogs. Let's say we ignore the dog IDs, right? We don't want to diff that. And then on line 6, we can summon our default dog zoo differ, and we start configuring it, right? First of all, when we are diffing employees, we want to ignore their age. We want to ignore the hours worked, and also want to make sure that we pair the employees by name so that we get a nice diff, just in case they're out of order. And also, because we already have this configured dog differ, right? We want to be able to use it. So the configured dogs differ on line 4, we want to reuse it for when we're changing the behavior of our dog zoo differ. So you can replace the differ at this path. So when we're comparing dogs, we're going to use the behavior of this dog's differ. So talking about a path expression, we showed you the .each, right? For lists, for vectors, any sequence. You can do the same with sets as well. So previously I talked about the behavior of sets being using equals, right? That's not too useful because if anything is different, it's gonna completely blow up. So now if you compare things up, you're comparing two sets of cats or dogs, you can just pair them up by their name, and now you get a nicer test output. For maps, you can configure how the values are diffed by calling .each on it as well. For case classes, you can change how a particular field is diffed. And also you can also configure how a particular subtype of a seal trait, or aka enum in Scala 3, you can configure how one of the subtypes are diffed by using like the subtypes. You can traverse down the differ into the differ of the subtype and change it. So here's a final example to show you this kind of deep configuration. Let's talk about office capacity. Right, everyone working from home. We have a smaller office. Want to make sure everyone is can work from office if they want to, and they are dressed correctly if they are working in office. So we have different types of people. We have contractors, which we assume will always wear the right clothes, and we also have our employees, who they will wear different things depending on their mood. And we have our case class for office capacity, people working from home, and then in the office it's a map because we have seating plans, right? People sitting in different places. So into our test code, we do the same thing. We derive our default instances. So for person, and then we derive it for office capacity. And then on line number 5, we start configuring our differ. First of all, on line 7, we want to say, if you're working from home, your employee working from home, we don't really mind what you're wearing, right? Because you're not meeting customers. You're not going to think you're unprofessional. And also when we are comparing people working from home, we want to make sure we pair them by name, because again, this is a set, right? So we want to pair them by name so we get a nice output. So let's say we run some example tests and we should probably see an output like this. So you might remember that we were saying that if you're working from home, we ignore what your attire is. So we see Sarah, right? We don't really mind what she's wearing. She's working from home. And then we have this kind of contractor not equal to employee. So what is this thing? So what's happening here is that we are expecting an employee named Paolo, but then somehow Paolo turned into a contractor, right? Actually, like when we check their statuses, oh, Paolo is a contractor now. Not sure what happened there. So this is what the output you get when you have two different seal trait. So you have a seal trait, right? And then you have two different subclasses that don't match. In the office, we have Percy. He's sitting in his seat, which is good. But then he's not wearing the right clothes. He's meeting the customers. So that's not good. He'll probably get a stern conversation with the boss next week. Okay, so some final tips. You can also use this way to construct your differ. So for example, sometimes you might have a small, simple class like, say, the Java util UUID class, right? You just want to, you can compare them using equals, and you want to quickly create a differ instance for it. So you can use differ.use equals, square bracket UUID, and then tell, and then you can get the differ instance for UUID that way. So if it fails, it's going to print it out using toString. If you're using IntelliJ, then you can also get nice outputs in right. You can run your test in IntelliJ, and then each test failure you can get this nice output. But just be mindful that by default, IntelliJ colors everything red in the output, which kind of breaks everything about our color scheme. So you probably want to turn that off, and this is how you would turn it off. Yep, and that's all I have today. I want to say thanks to some projects and some people. So people at Software Mill, there's Scala Consultancy. They have a library called diffx, which does very similar things. So when I started building this, I took many inspirations from them. I also want to thank everyone who worked on Scala 3, right? The tooling, the language itself. It's been quite fun working in it. Givens save you quite a few keystrokes because you no longer need to name your implicits, and macros are pretty fun as well. Yeah, that's all I have today.